thing we're going to look at is we're going to actually see how many of those calls that are coming into our call center we actually refer to agents. So remember that when a customer phones in, they have the option of following that prompts by just pressing buttons on their phone until they give up, or they can actually hang on and wait for an agent. And it's only when they wait for an agent that the call gets put through to an agent. So it's only then that it's actually taking up our resources, our clients. So we need to figure out what percentage or fraction of that calls that are coming in are actually going through to agents, because that is the information that we need to do our resource planning. Okay, so if we go back to our data, we see there's another variable here called agent requested, and that's just simply true or false. So if an agent was requested, then it's true. If an agent wasn't requested, then it's false. So what we're interested in is that we know how many calls we're getting in. So we now want to see what is the split between those calls that require an agent and the calls that don't require an agent. Okay, so again, we're dealing with the categorical variables, so we can get that split by using the table command. So let's play around with the table command again. Okay, so I'm going to use table. In this case, as a first shot, I'm just going to tell R to just give me an overview of how many calls over the course of a month required an agent and how many didn't. So I'm just going to say, give me a table of the agents requested. That's the only one. Okay, so if you run that, that's false or true. So false means the agent wasn't requested, true means it was. And we see that about 25,000 records or calls did not require an agent, and 31,500 required an agent. Okay, so we already know now, just by running that most of the calls that came in through a month actually required an agent. So we can calculate the percentage just by saying, okay, divide that by our number of calls that we got, which is the number of records that we have, which we can get with the nrow command. So if you run that, we see that it gives me an error because it only has to refer to the frame, not to an actual variable. Okay, so if you run that, we see that 45% of our calls did not require an agent, and 55% of our calls require an agent. Okay, so it's a little bit tempting to use these numbers as is, but this is on a very high level. So we might be using incorrect data. We don't have a complete picture of our data if you use a number as is. So for argument's sake, it might be the case that on Monday people are mad. They just want to shut out the bank so that everybody phones in and waits for an agent. It's not that fun to type in numbers very hard. It's much more fun to shout at people, to shout at the agents. Okay, so let's say on Monday, 100% of our phone calls actually require an agent. On Fridays, people are more chilled, so then they don't mind going through number prompts. And on Fridays, people don't actually wait for agents at all. They just use the number prompts. So again, that is going to influence our resource requirements. So it's dangerous to just assume that's a good value to use without looking at the data. Okay, so similar to what we did over there with the end calls per month, which we split over the date or the day of the week, I actually want to get a table showing me the split between the false and true, but I want to see that split for every day of the week. So what I'm going to do there, I'm just going to tell R, so okay, I want the agent requested, and I want you to give that to me for each day of the month, our study period. Okay, so now I'm just going to force in two categorical variables in there. So I'm now telling R to please count the number of trues and false for each day of the week, for each day in our study period. Okay, so if you run that, there we get it. So we get on the second, about 856 calls did not require agent, 1,000 did. On the third, 845 didn't, 1,079 did. Okay, so we can see there, again, it seems to be fairly consistent. There's a little bit of variability, but it's pretty solid in terms of the number of calls that is split between those two groups. Okay, so we can draw a bar plot of this as well. So let's just say bar plot and throw that whole thing in there, calculate it, and there we have a bar plot between our true and false. We have no idea what our true and false is. Usually R sorts this alphabetically, so that should be true and that should be false. The first one is over there. Okay, so this is useful. Again, we can't really see a big trend there. It's a little bit tricky because our bars are not the same length because there's sort of randomness in the number of calls that we're getting. So ideally I want to have a bar plot of the actual fraction for the split between those things. Okay, and we can do that quite easily in R. So to do that, I'm going to use the probability table command. So first things first, I'm going to save the data, this table. So I'm going to say it's agent calls per day is equal to table, that one over there. Okay, so we can run that. And now I'm going to tell R to please calculate the probability, or sort of the fractional split between the true and false. So I'm going to use the prop table command there. I'm going to call that on the table there that we've already done. And now I have to tell R, okay, which way do you want to calculate the probabilities? Do you want it to be that way or that way? Okay, so this way means that R will basically take the sum of those values and then divide each one of that number by the sum of those two values, which is exactly what we want. So we want a fractional split per day. So we want it to be done per column. And to instruct R to do that, we just have to tell it 2 at the end there. If you do it with a 1, then R is going to do it per row. So it's going to do it for all the falses. What fraction of falses was there per day? But we don't want that. We want it per column. So let's press enter and run it. And there we have our values. So there we can see it's about 45%, then 54, 43, then 56. Okay, so just make sure that you did this correctly, that it actually adds up to 1%. If we put the 1 there, then we would have gotten a weird number. You'll see it's like very small numbers because all those numbers in a row count up to 1, which is not what we want. We actually want it per column to count up to 1. Okay, so there we have our prop table. And again, we can draw a bar plot of this. You can say, give me a bar plot of prop table over there. And there it shows us that it is fairly consistent as well. The split between people that's waiting for agent and people that are not waiting for agent. Okay, so this is pretty good. It will simplify our calculations a little bit. So again, we can use on a single value and just inflate it a bit to get to the actual staffing levels. Okay, so similar to what we did over here, we actually got a number, a fraction that we can use. We want a fraction here as well. So we want to see, okay, what is a fraction or the percentage of calls coming in that require an agent? Okay, so in this case, we're going to have to be a little bit clever. So we're going to have to decide, okay, what values do we want? So we want the fraction of calls that require an agent. So we just want this true row over here. We just want all those true values over there. And we can get that quite easily using indexing. Okay, so we have our probability table there. So I want to save that probability table quickly. I'm going to say the probability of call require agent per day is equal to that one over there. So if you run it, call it, just make sure it's the right thing. Yep, it's the right thing. And then for the number of calls that did require an agent, the fraction there, I'm going to probability call require an agent per day. I want to look at the second row. So I want all the values in the second row. So how do we tell R to do that? So we're going to have to use indexing. So if we say I want value 1, let's see what it returns. It returns 0.4531, which is that value over there. So if we're telling R, I want value 2 in row 1, which value is that going to give us there? Let's just play around and see. Okay, that gives us 0.439, which is that value over there. So to tell R to give us all the values in row 1, all we have to do is we just have to remove that. Then it will return all the values in row 1. Okay, so if we do that, great, it now returned all the false values. So it's that row there. We're not interested in that one, we want the second row. We want the fraction for the number of calls that did require an agent. So all we have to do is we just tell R, hey, please draw row 2 for me. Okay, so call that. Let's see if this looks better. And yes, there we have our 54, 56%. Okay, so now we can do summary statistics on this one, just to see what that distribution looks like. And again, seems the fraction is pretty low. So we have our mean of 0.55, we have a first and third quarter there, 0.55 and 0.4546. Again, so it's a small range of a little bit more than 1%. Okay, so we can use this value. This is the value that we're after. So let's go over there and say the fraction or percentage of calls requiring an agent is equal to the mean of that value over there. Okay, run it quickly. Yep, there's our answer, and it's correct over there. So we know that of the calls that are coming in a day, about 55% of them will require an agent. Okay, so now we can actually go back to our previous stuff. So we know we currently have 75,000 clients, and the number of calls that we get per day for that 75,000 clients, we know what that is. And so now we can calculate how many calls do we expect when we have 100,000 clients to actually go to a call agent. Okay, so it's going to be pretty much the same. We're going to say the n calls to the agent. That's going to be the number of calls per day new that we're going to get for the 100,000 clients times the percentage of calls that require an agent. Okay, so run that, and we see that we expect about 1,400 calls per day to come in when we have 100,000 clients to actually go to an agent. Okay, so we have to set up our staff or our call center to deal with 1,400 calls per day. So we're going to have to appoint agents to deal with that 1,400 calls per day. Okay, so we're almost there. We now have an idea of how many calls are actually going to come in that has to go to agents. Remember, the number of calls that come in requiring agents is going to dictate our resource requirements. So the next part is to actually look at, okay, but what's the split of these calls between our different client groups, between platinum, gold, and silver. And once we have that, then we can actually look at our staffing ratios to determine how many people we need for this call center.